Good afternoon friends, I am Jigar Ratnottar from Atmeya Institute of Technology and Science for Diploma Studies, Rajkot. Today we are going to start our topic with the dielectric circuit, and our main topics in a dielectric circuits are like a capacitor, capacitance, types of capacitor, series and parallel form of capacitor, and several examples based on that circuit. So let's start our journey towards the dielectric circuit. Capacitor, it's a main component of resonant circuit. As we all know that the tank circuit R, L and C component, that is a form a resonant circuit. So capacitor is one of the most important element of that circuit. How can we form the capacitor? Generally, the two conducting plates separate with each other, parallelly separated with each other at some distance, and within the distance we have to put the dielectric material. So if we sandwich the dielectric material between two conducting plates, then it forms like a capacitor. Some of the materials generally used in a dielectric as a dielectric material like mica, paper, air, vacuum, etc. The main function of capacitor is to store the electrical charge between the two conducting parallel plates. As we all know that the capacitor is a passive device, it's not an active device. There are two types of device, active and passive. Resistor, capacitor and inductor are the passive elements. The passive elements are those who cannot generate the energy through it. Instead of that, they are the device which expose the energy, like a capacitor. So it's a passive device. The capacitance value are normally smaller. It's in the range of microfarad, nanofarad and picofarad. Now this is the construction of capacitor, how the capacitor is formed. These are the two conducting plates. You can see that the plate 1 and plate 2, and between that two plates we just place the dielectric material. So dielectric material is nothing but it's a kind of insulator. So due to that, no current can flow from the plate 1 to 2 or plate 2 to 1, that is the conducting plates. So we can say that in a capacitor, in a dielectric material, through the dielectric material, no current can flow through the device. Here at the bottom of the slide you can see the view of a capacitor. Capacitor is sometimes referred as a condenser in a simple passive device. So if anywhere you heard the word condenser, it's nothing but a capacitor. The conductive plate, metal plates of a capacitor can be either in the form of square, spherical, cylindrical shape, or it's a strip form. So there are different kinds of conducting plates are available in the market. So here is one of the view of the capacitor, which is in the form of cylindrical shape. This is one animation which shows the principle of capacitor. That is a plate 1 which holds the positive charge carriers, that indicated with the positive sign. The another plate, these both are the conducting plates. What happens when the charge carriers move toward the plate 1 to 2? Whenever we are applying the supply, some of the charge carriers are attracted to plate 1 to 2. So the potential difference generated to the two different plates, and that is the principle of capacitor. So you can see that the capacitor is a device which used to store the energy or charge carrier. This is the construction of a capacitor. At the right side you can see the symbol of capacitor. This is the two parallel conducting plates. Now, as from the figure we can see that the two conducting plates are connected with a battery of V voltage. Now suppose we are assume that one of the switch is in the series of supply voltage, then exactly what happens? Initially, if the switch is open, then no current can flow from the positive to negative terminal of the battery. It means it doesn't have any potential difference between the two plates of the capacitor. Now the case number 2. Once we are closed the switch, then exactly what happens? The switch is now the closed loop. So the resistance is 0 for the current. So current can easily flow from the circuit from the positive terminal of the battery to the negative terminal of the battery through the two conducting plates, which behaves like a capacitor. So as per the figure you can see that the left hand side of the conducting plate contains the positive charge carrier, and we all know that the charge carrier is indicated as a Q, and the negative plate, the right hand side plate, which behaves like a Q minus, that is the plate which contains the negative charge carriers, and between two the material which is used is a dielectric material. As we already discussed that this was the air, mica, paper, wood, etc. So this is the basic phenomena of the capacitor, how exactly the capacitor is made. Here you can also see that the two metals or the metallized foil plates at a distance parallel to each other. So we can make the capacitor by separating the two conducting plates at some distance. Because the capacitor has the ability to store the energy of electron in the form of an electrical charge on the plates. So this is biggest function of the capacitor, to store the electrical energy in the form of electrical charge, that is Q. So you can see that if we want to get the higher energy, we have to make the larger conducting plate. So we discussed that the greater will be the charge that the capacitor hold if its conducting plates are larger. In other words, the larger the plates, smaller the distance, more the capacitance. So we can see that the capacitor depends upon the two parameters, that is the conducting plates, area of the conducting plates, and the distance between two conducting plates. So C is directly proportional to the A and inversely proportional to the distance D. Now, as we already saw from the figure, that whenever we are applying the voltage to the two conducting plates, which behaves like a capacitor, then what happens? We are able to find out the charge, that is Q, generated to that plates by applying the potential difference, that is the EMF voltage V. So that term is again known as a capacitance. So the capacitance is nothing but the property, or it is the process which the capacitor holds the electrical charge towards it. So capacitance C, here you can see that the equation of the capacitance, that is C equals to Q upon V, Coulomb. Coulomb is the unit for capacitor. Here the C is a capacitance, Q is the electrical charge generated to one of the plate of a capacitor, two conducting plates of a capacitor, and V, that is a potential difference or applied voltage to the capacitor. So according to the equation of C equals to Q by V, we are able to give the definition of capacitance. That is, the capacitance is nothing but the ratio of charge on one of the plate of a capacitor, two conducting plates of a capacitor, to the potential difference or the voltage applied to that two conducting plates. So the property of capacitor is to store the electrical charge on its plates, conducting plates, and that is known as a capacitance. So to measure the capacitance, we can easily find out we can easily say something about the capacitor. So different kinds of capacitor available in the market is depends on the dielectric material, because all the dielectric materials has the capability to pass the current through it or some of the amount of to block the current through it. So according to that, the different kinds of capacitors are with the different capacitance value are available in the market. Not only that, but the capacitance is also the property of capacitor, which resists the charge of the voltage across it. So this is again important property of the capacitor, which directly related to the capacitance. Ultimately, we can say that the more the area of the conducting plates get greater the capacitance. You can see that the capacitance is C is directly proportional to the area which is covered by the conducting plates, and this is first parameter which the capacitance is directly proportional. The again important parameter of the capacitance is the distance d of the two conducting plates. This is our plate 1, this is our plate 2. So this is the area covered by the plates and this is the distance. So for that, the capacitance is directly proportional to the area and inversely proportional to the distance. So we can write like that: C is proportional to the A by D. So the value of the capacitance is directly proportional to the area which is covered by the two conducting plates and the distance between the two conducting plates. Now, the unit of a capacitance. As we already know that the unit of the capacitance is the Faraday. It is defined as a capacitance as the capacitor has the capacitance of 1 Faraday if the charge if the electrical charge, that is Q, is 1 coulomb and the applied voltage is a 1 volt. So according to the definition of capacitance, that is C equals to Q by V, Q equals to 1 coulomb and V equals to 1 volt. So we can find out the capacitance, that is 1 Faraday. But friends, the Faraday is a very big unit for the capacitance. So in practical, we cannot prefer the Faraday. So instead of the Faraday, in the practically form, we can use the smaller units like a microfarad, nanofarad and picofarad. See, these are the standard units for capacitance which are generally practically used. The microfarad. 1 microfarad equals to 10 raised to minus 6 F. That is Faraday. Micro, that means 10 raised to minus 6. Nanofarad. 1 nanofarad equals to 10 raised to minus 9 F. And the picofarad, that is 10 raised to minus 12 Faraday. So we can see that the picofarad as the smaller unit, standard smaller unit of the capacitance. But generally the capacitance are available in a microfarad or in a nanofarad form. So these are the standard units for capacitance. instead of Faraday we just prefer the micro, nano and picofarad. And these are the values for micro 10⁻⁻⁶, nano 10⁻⁹, and pico 10⁻⁻12 Faraday. Just go through one example. A capacitor which has the capacitance 250 microfarad and which is connected to a battery of 6 volt. So the capacitance has the value C equals to 250 microfarad and the voltage, that is V, it's a 6 voltage. So with the using of the equation C equals to Q by V, we can write like that: Q equals to C into V. So C is a 250 microfarad, that is 10⁻⁶, as we already know that, and V, that is the 6.0 voltage. So to find out, to calculate that equation, to solve that equation, we can find out the value of Q, that is a 1.5 into 10⁻³ coulomb, or we can say that it's a 10⁻⁻3, it's a milli, so 1.3 milli coulomb. So this is the electrical charge generated to that capacitor. Now the next one is the number of excess electrons on the negative plate of the capacitor. As we already know that the Q equals to smaller q equals to 1.6 into 10⁻⁹ coulomb. So if we divide that, our total, if it is for the 1 electron, then the total electrons are 1.5 into 10⁻³ coulomb. So just dividing that 2, we can find out the total number of electrons excess towards the negative plate, and these are the 1.5 into 10